This next talk will explore extending the Figma canvas into the physical world. Please give a warm welcome to Frederik Ueberschär and Sam Thorne.
So, hi, I'm Frederik. This here's Sam.
Hi.
Today we will talk about prototyping for the physical world and share the story of how we sped up reviewing our UI design work from 6 months down to just 2 minutes. So, Sam and I, we work as designers for creative technology at Electrolux in Stockholm. We build home appliances, so everything from ovens, washing machines, air conditioners, and distribute them all over the world under our brands Electrolux, Frigidaire, and AEG. There's a good chance you've seen or even interacted with one of our products at some point, maybe even have one in your own home. Over the past couple of years, we've seen the industry shifting from static interfaces with printed graphics to smart appliances with rich displays that add extra functionality and customization. And with this shift came new challenges. So where old school user interfaces were mostly static, modern appliances consist of hundreds of screens and dynamic flows that adapt to the user. Designing for this new generation of products meant completely reinventing our design process. In our job, Sam and I sit between design and engineering, combining skills from both worlds. We work closely with the design teams who create those interfaces of these products, interfaces that will live in someone's home for 5, 15, 20 years, and explore new interaction modalities with code and electronics. One of our jobs is to help bridge the gap between what designers create in Figma and what ends up on the physical product, bringing design and engineering closer together. In today's talk, we'll take you into the world of designing for appliances and the considerations that come with it. Over the years, we've built many custom tools like Figma plugins and one-off prototypes. But in today's talk, we want to show you 2 highlights, tools we've built that extend Figma into the physical world. One tool for adding additional input to Figma, and another for showing design output on an appliance screen.
So the best way to introduce you to our world is probably to compare designing for appliances to how we design for a web or app. Normally, you would meet on the canvas in Figma, create a few frames with a flow that you'd like to explore, add components from your design system, link them up as a prototype, and then see and test the result in Figma on a real phone. You can be confident that what you design and preview in Figma will be very close to the end result, and you can use this for iterating on the design. Now imagine you want to design the first flow for an oven, trying out how to navigate the interface on the screen with the tactile rotary dial on the left. Different to the iPhone prototype I just showed, the product we now design for only has a fraction of the pixels, a limited color palette, 4 millimeters of glass in front that changes the appearance, with a user's viewing angle differing vastly from your desktop screen, and not only touch input, but also additional buttons and a rotary to interact with the screen. The appliance might not even exist yet, so it takes weeks or months to get to see your design in the real hardware. How do you start designing and prototype in this scenario?
So when breaking down the goal, there are 2 problems we need to solve. First, how can we get additional input, user interaction, like this rotary, into our prototype? Like a huge number of our products use some kind of tactile input, and the rotary is something that we can't just simulate with a display. You need to use it with your hands and get a proper idea about how your design will feel. And second, how can we see our design on an appliance display? Again, like Sam just mentioned, one that can look and feel very different to your iPhone or your desktop screen. Let's start with the input. So the flow we are trying to build here is simple. The goal is to start on the home screen, and then when I turn the dial to the right, we want to go to the next screen, and then when turning it the other way, back to the previous screen. If you ever prototyped in Figma, this window here will look very familiar to you. It's where you can set a trigger for an action, like navigating to another screen. Unfortunately, on rotation, or something like this, is not one of them. But what we do have is a trigger called key/gamepad that, well, you guessed it, triggers when you hit a key on your keyboard or controller. We can use this to navigate the screens. We just need some hardware that uses this logic to bring the dial interaction into our prototype. This is why we built Figma rotaries. Actually, Sam has one right there. They are small USB-connected devices that bridge the gap between Figma and the physical world. Each one packs a little microcontroller and a rotary encoder. When connected to a computer, the microcontroller acts like a keyboard, translating the rotational movement and clicks to the keyboard presses that Figma can read. Going back to the simple prototype, when connecting the Figma rotary, I can now use it to control the flow. Rotating right triggers an arrow key to the right, left to the left. This already gives me a good idea of how the design will feel. The cool thing is, everything we've used here is simple off-the-shelf electronics, put in our own 3D printed housing, making it cheap and fully customizable. If we want to design a quick holder to hang it over a display, we can. And when we wanted to test the design with multiple rotaries, we adapted it to include a little switch that changes the mode from sending arrows to sending WASD keys, so they don't interfere with each other. And when we wanted to explore backlight behavior for rotaries, we made it smaller and put it in front of a display. So instead of controlling LEDs, we used the display itself to light the rotary with a shape in Figma. With this, designers can experiment with light, not spending any time on building with electronics. This slider here is an example where you can apply the same approach as simple if this, then that logic to other types of input. Or here, this light sensor using ambient brightness to trigger an animation. Or this color sensor mapping an object color to drawing a shape on the canvas. With some sensors and the keyboard emulator as a bridge, we can bring almost anything into Figma.
So input, getting something into Figma, is only half the equation. Output, how we see our designs on a display, is just as important. Displays are all around us. There's one in front of me, I have one in my pocket, another on my desk, and one hanging in my living room at home, where my daughters Clara and Sarah are watching now. All those displays can show at least 16 million unique colors. Modern smartphones or laptops up to 1 billion individual colors. We've gotten so used to amazing displays that it's easy to forget just how remarkable it is. Your screen is pushing millions of precisely colored pixels at 60 to 120 frames a second. 1 billion pixels every second. It just works, you plug it in, we rarely stop to think about it. And to be honest, I rarely thought about it either until I started designing for appliances. In our world, things look a bit different. We work with a lot of non-standard components, industrial-grade displays with high heat and moisture resistance, special aspect ratios to fit our products, but with a trade-off. Lower resolution, slower response time, and often a limited color palette. Designing for this kind of display requires extra attention. Every pixel matters, and getting a feeling for the result while designing is crucial. If you've ever gone shopping for a new couch, you know the feeling. You did your research, you measured your living room, you found one that you like. You go to the store and it looks perfect, the right color, the right size, you can totally picture it. Then you get it home, you put it in your room, and it's not quite what you had in mind. The color looks a bit different in your lighting, it feels a bit cramped, something is off, and you don't find out what until you're actually living with it. That's what it feels like to design screens on a large studio monitor. And then seeing the result on an appliance display. Our designers were stuck in the furniture store, making their best judgments under showroom lighting, hoping it would hold up in the real world. Often it did, but sometimes we'd end up with a couch that doesn't quite fit. Take color as an example. So this big guitar pick is the set of colors visible to the human eye. This triangle area in the middle is a common color model for displays called sRGB. It shows the range of colors that most displays can represent. Most likely, you will be used to working in 24-bit color. 24-bit because there are 8 bits for red, 8 for green, and 8 for blue. 8 bits of binary can represent the decimal numbers from 0 to 255, which is why your color palette looks like this. In other words, you get a range of 0 to 255 for each primary color, and all available colors are made by combining those 3 values. So 256 multiplied, you end up with 16 million possible colors in the sRGB triangle. In the appliance world, we're often working with displays that can show only 16 bits of color. They use an RGB 565 model, which means that there are 5 bits for red, 6 for green, and 5 for blue. 32 by 64 by 32. That's 65,000 in total. It still produces a colorful image, but the palette is limited to under 1% of the 24-bit color palette. Still sounds like quite a lot, right? And for a lot of UI work, especially with flat colors, it's fine. The problem shows up the moment you try to use gradients or soft shadows anywhere you're blending smoothly from one color to another. Here it is in 24-bit, and here it is in 16-bit, and suddenly 65,000 colors isn't nearly enough. And you start seeing something called banding, visible steps between colors where the transition should be smooth. What you see in Figma is not what you get on the hardware. For a designer who has been carefully crafting a visual style, that gap can be a real problem. We know the importance of previewing our designs on a real screen, not only to judge the colors, but also the size and the positioning of UI elements. What makes this process difficult is that the types of displays that we work with can't just be plugged directly into your computer. Instead of HDMI or USB-C, they have a flexible ribbon cable. And they use different protocols like parallel RGB or SPI to receive the image signal. Most of them do not even support the minimum resolution that macOS requires for a display. Which means that for a long time, seeing a design on a real screen could take 6 months or even longer. It was a slow and expensive process, requiring an engineer to actually translate the design into actual code, and by that point, it was often too late in the development process to meaningfully adjust anything in the design.
So we had this moment that really stuck with me. So when I joined Electrolux, we were designing the UI for Cooktop with a built-in display. It was an exciting project, definitely new territory for us. And as usual, the design came together in Figma, got handed off to engineering, and the development kicked off. But there was no way for us to preview it on a real screen, no way to see it behind real glass. So we made our best judgment on a big monitor, and were confident they would translate. But when the first physical samples arrived, some UI elements were too small to read comfortably. Others were partially cut off when you looked through the glass at an angle, something that no one anticipated on a standard display. So designing for embedded hardware is genuinely complex. And when you're working with brand new electronics, things simply take time. And at this point, late in the project, most of the design was already locked in. Changes were slow and expensive to make. So the project still launched as a success, went on to win multiple awards, thanks to a great effort from both engineering and design. But this experience was a big part of why we knew our process needed to change. We could have found many issues earlier if only we had a way to see it. This story also happened just around the time we fully transitioned our work from Adobe XD and Photoshop to going up to Figma. So we had our motivation, we just experienced the gap in our process, and from that frustration and the tool change came our moment and our first idea. So Figma is a website, right? I know, sounds simple. But if a design can run a browser, it can also run Figma prototypes. Our thought was, can we build a magic box that connects Figma on one end and our custom displays on the other side? So this is what we did. We just call them Figma Displays. So you can think of them as the Figma app, but for our niche hardware. Let me show you how they work. Here's my MacBook running Figma, and right next to it, a Figma display. Once connected to power, it takes a minute or so to start everything up, but then it shows a one-time connection code. Over in Figma, I open a plugin we wrote, enter the code I see on the screen, and then just like that, the two are connected. From here, I can select any frame in my design and send it to the display. It shows up almost instantly, giving me an accurate preview of the design right there on a screen with the correct size and resolution. I can spot issues with readability, visual style, or touch target that might not be as obvious on a bigger monitor. A static preview is already super useful, but what I actually really want is to test the flow, navigate between a few screens. For this, I can also send my design as an interactive prototype. The display receives a link from the plugin and opens it in a new tab. It takes a few seconds to load, but once it's up, I can preview the flow and interact with it on the display, just like a user would on a real product. The cool thing is, any changes I make in Figma update right away, so I can iterate quickly, make informed decisions, and show my design to others, all without waiting for an engineer to build anything. And just like that, what used to take multiple months can now happen within minutes. For now, we build Figma display variants for each screen size we currently use, from small 3-inch screens to bigger and wider 8-inch displays. So let's open one up and see what's inside that make all of this possible.
So at the core is a Raspberry Pi. They're small, low-cost single-board computers, or they used to be low-cost before memory prices went through the roof. Our first version did not have a cooling fan, but we decided to change that when we saw the Pi slowly creep up to a boiling temperature inside the case. The Pi is connected to a display, sending the image signal and receiving the touch signal in turn. A small button gives us extra input to control the device once it's closed up. We pack everything into a custom 3D printed housing. This protects the electronics, lets them stand upright, and makes the display portable, which was important as we saw designers start to take them to meetings, presentations, and to work from home. On the software side, we have 3 main components: Figma and our plugin on one side, the physical display running our Linux, Python, JavaScript stack on the other, and a server between the two. The server in the middle functions as a bridge, connecting the two components via MQTT. MQTT is a fast messaging system. It's like WhatsApp for IoT devices. It passes data between our devices, even on slow or unstable connections. When the plugin is started, it connects to our server, waits for the designer to enter a connection code, and then checks the code against all available displays. Connects to the matching display, fetches its details like status, size, resolution, pixel density. And when sending a design as a static image, it converts the current selection to a base64 encoded image and sends it off as a payload. For sending a prototype link, it constructs a shareable link that points to the selected screen and adds additional parameters that tell Figma how to display the link. On the display, it's a bit more complex. We're running Raspberry Pi OS and then a custom Python application. The application starts up automatically when the Pi boots up. It sets up the web browser and handles incoming commands to the display. Once the display is online and connected to the server, it publishes its unique connection code. It then shows the code and advertises itself as available. Then, when a new command comes in from the Figma plugin, it makes a decision. If the data type is an image, it gets decoded, saved to storage, and displayed. If it's a prototype link, it opens it in a browser tab. And of course, our designs are confidential, which means you have to be logged in to see them. So for this reason, we use Playwright. It's an open source library that allows you to go through the Figma login flow automatically. No keyboard required.
So as we started shipping these displays to our design studios around the world, we needed also to cover more edge cases. Without local network access ourselves, the displays and the software needed to handle more of the functionality, like fetching new software updates, updating credentials, connecting to new Wi-Fi network, etc. But going back to the original goal of designing and testing this flow with a rotary and seeing the result on an actual screen, by combining the Figma rotary and the Figma displays, we can get really close to the end result. Send the flow to the display, plug in the rotary via USB, and we have a testable result that starts feeling very close to the real product. It's not 100% the same, but that's also okay. So even an approximation like this helps us find most issues and allows us to test new ideas with our users. And as with the Figma rotaries, the working principle of the displays can be extended further. In the end, this is a Pi running a browser, so we can connect almost anything as a display. We're currently exploring how we can add circular displays, e-paper panels, or LED matrices to our setup, and use Figma to design for all of them. With these devices as a bridge, our canvas doesn't end at our monitor anymore. And we're not alone. Like, if you're working any kind of product development involving physical digital devices, many of the challenges we share today will sound familiar. We heard some in the talks just earlier. With the project we showed today, 5 things changed for us, and they're connected. First of all, our iteration time shortened. Designers can confidently test and iterate on a digital design the same day. Our prototypes also got closer to reality. We can catch more issues early before they become expensive and test the design with users before the actual hardware is finished. And with that, our conversations within design and with other stakeholders got a lot richer. Seeing work in the physical world and being able to look at it together, we leave this conceptual space and can focus on the practical details. When we take over more of the early exploration, we open up time for engineering to focus on what they do best, building an implementation that works on the actual hardware. And lastly, we saw the digital and physical move closer together. Electrolux is a hardware company at heart with a long 100-year history of building physical products. With our work, we continue to bridge that legacy into the digital age. Closing the feedback loop for us changed the whole process, not just the speed. But here's what we've come to believe. The specific hardware constraints don't matter. You can work around limited hardware. What matters is clarity around design constraints and opportunities. To provide that clarity, we build projects that are meant to be obsolete. The Figma displays and the rotaries, they exist because there's a gap between the canvas and the real hardware. When that gap closes, that's a win. We build those disposable tools on purpose. We want them not to be needed anymore. When one gap closes, though, it's our job to find the next one and then close that one too. And there's still plenty of gaps left to bridge. We'd love to quickly prototype how an interaction in Figma can control the hardware, how it triggers an oven light, a fan, or a door lock. We haven't even talked about prototyping connected behaviors across devices either, linking one prototype to another. If anyone from Figma's in the room, we wouldn't say no to a few features that make our lives a little easier. So what's the takeaway? Same as all of you, we like using Figma for designing together. But in standard form, it wasn't quite enough for our use case. Rather than finding an alternative, we extended it. For us, Figma became a web platform that we can shape around our needs. Everything we showed you today, the displays, the rotaries, were built with easily available tools, plugins, some electronics, a bit of code. None of this requires a factory or large budgets. So the next time you hit a gap in your own design process, a disconnect between your prototype and reality, look at the tools around you and ask yourself, what would it take to build something that bridges this disconnect? It might not be a Figma display. It might be something only your team needs. But the hurdle to get started is probably a lot smaller than you think. Modern coding tools make this kind of tinkering more accessible than ever and a lot of fun. And if you want to start somewhere, please come find us after the talk. We are super happy to share more about our process and what we learned. Thank you.
Thank you.